Okay, so angles and measures, super easy day. It's just gonna be a little bit of writing on the first page due to some vocab. Okay, some of the stuff you may already know, and then there's something that maybe some definitions are gonna be just kind of a different definition than what you're used to. But the first thing we're gonna start with is a ray. You learned what a ray was probably in elementary school, maybe middle school. I'm guessing elementary school. Like fifth grade in math. But a ray is part of a line. So a line extends infinitely in both directions. We put arrows at the end of a line. A ray is an endpoint and an arrow. Okay, so in this example, we see our endpoint here, okay, all the way through to our line. So it has an endpoint and has one end with an arrow. So it only extends infinitely in one direction. Okay, a vertex is the starting point of a ray. So in this case, right here, V is our vertex. Okay, if we're looking at the ray above, V is our vertex. An array and a vertex are important because they make up an angle. So that's kind of where we're going with this. So an angle is two rays, okay, that are drawn from a common vertex. So if we were to look at drawing this, we have a common vertex. Okay, I'll just label it V for vertex. Common vertex, and then we have one ray going from it and another ray going from it. So ray 1 and ray 2. So an angle is a common vertex and two rays that are drawn from that common vertex. Okay, so when we are drawing an angle, one of those rays is going to be an initial side. That is your starting side. Okay, if you look at our examples, okay, right here, our initial side is always this bottom side. Okay, when we're working with drawing angles, the initial side is going to be on the x-axis. It's going to be flat. Okay, the terminal side is that other ray, the other side of your angle. So if you look at our example, okay, our terminal side is right here for each of those. Those are your terminal sides. So initial side, terminal side, those are the two sides of your angle. Now, what questions do we have so far? Any questions so far? Hopefully pretty easy. Okay. Anybody still writing? Good? Okay, you're good. Keep writing. Okay. Okay, so our next definition is called standard position. All that is that your initial side is on the positive x-axis. So when I look at drawing an angle, okay, there's my coordinate plane. All this means is that your initial side is right there on that positive x-axis. And those are the kind of angles that we're going to work with. We really won't work with too many crazy angles here. Mostly they're going to be standard angles. Okay, we we have a positive angle when it's going counterclockwise. It's going counterclockwise, we have a positive rotation. So if you look over here, okay, this one has the initial side right here. It goes counterclockwise. That's positive. Okay, so that's our positive. Negative is just going to be going to be clockwise. So here we start here, our initial side, we move down, okay, which is a negative angle, and that's moving clockwise. And one thing I do want to point out is both of these angles are in standard position because that initial line is starting on that positive x-axis. Okay, last thing is our degree. Degree is a measurement to show a rotation from your initial side. One rotation is 360 degrees. We know a circle is 360 degrees. Moving on, okay, our Greek letters. You won't have this box right here. That's fine. You don't need to write this down. Okay. But our alpha and our beta. Alpha. Actually, do I want to do that side? Let's do the side first. Let's go ahead and do this. Okay. So our right angle, we know that measures 90 degrees. Okay. Our straight angle is 180 degrees. That's supplementary. We've talked about supplementary angles in geometry. Okay. But the revolution thing is a little new, so I'm going to let you write this down. I'm going to explain our revolutions. Okay. Take a look up here at the board. So let's just start with 90 degrees. Okay, 90 degrees, we know, here's our initial side, here's our terminal side. We know what 90 degrees is, okay? But if we think about it in terms of a revolution, one revolution is equal to, how many degrees do you think? 360, we've already said that on the notes. Okay, one revolution all the way around is 360. So if we're going 90 degrees, if we do 90 divided by 360, that's 1/4. Or you can look at it, okay, and you can say, well, that's one box out of 4. Okay, so 90 degrees is 1/4 of a revolution. 180 degrees is half of a revolution, because here's our 180. Or you can do it this way, 180 divided by 360 is 1/2, bless you. Okay, 270. You do 270 divided by 360, that's 3/4, they're 0.75. So that would be 3/4 of a revolution. 45 degrees, okay, that one, 45 divided by 360, 1/8 of a revolution. So when we draw these angles, we're going to write them in degree. Well, we're going to be given the degree, we'll draw it, and we'll write how many revolutions it is. Okay, so this will kind of be helpful. And notice, all of these are counterclockwise because they're all positive. If it's negative, you just say the same revolution, but you would say clockwise. Okay. Let's talk about Greek letters really quick, just to kind of, I don't know, have you guys worked with Greek letters before? No? Okay. Alpha. is our first Greek letter, and I'm just going to do the lowercase of each Greek letter. Alpha is an A. This one, I don't know why, but it's the hardest one for me to draw. It's an A that's kind of like fancy. Or you can think about it, it's almost like half of the infinity symbol. Think about it that way. Okay, that's our alpha. Alpha is how we label a positive angle. So alpha is how we label a positive angle. Beta is a capital B with an extra, that wasn't very great, is a capital B with an extra stick at the bottom. Capital B with an extra stick, that's beta. That's how we label a negative angle. Gamma is a lowercase y with a loop. Looks like that. That's gamma. Okay, gamma is how we label an angle that's a full revolution plus some. So it's bigger than 360 degrees. Okay, so I put full revolution plus because that tells me it's going to be 360, greater than 360 degrees. Okay, and last, you have seen this a lot, is theta. Theta was used in geometry, I'm sure. Okay, that's how we usually label angles. In this case, theta is going to be how we label an angle in standard position. Okay, that simply means I could label all of these as theta because they're all in standard position. They all have an initial side on that x-axis. Okay, what questions do you have about vocab? Okay, that was a lot. Okay, so let's jump into drawing these angles. So if we want to draw 45 degrees, you probably already know what that looks like. Okay, we're just going to do these with coordinate planes. We're going to draw a coordinate plane. Okay, we're going to have our initial side on that x-axis. Okay, so we're going to start here. There's our initial side. So this will be a standard position angle. Okay, you know 45 degrees is here. There's our terminal side. Okay, we know that's 45. There's two things we need to write down. First, we want to write down how many revolutions is this. This one's pretty easy because I already have it on the board. How many revolutions? 1/8 of a revolution. Okay, did we move clockwise or counterclockwise when we drew our angle from the initial side? Counterclockwise. Here's our initial side. Okay, we drew it up here. So that is counterclockwise. Okay, we knew it was counterclockwise from the beginning because it was a positive angle. Questions on the revolutions or counterclockwise or clockwise? Go ahead and draw your next one. Draw that coordinate plane. Okay, now we're going to be at negative 90 degrees. It doesn't change where we start. So we're going to start our initial side on that positive x-axis. And if it's negative 90, are we going to move counterclockwise or clockwise? Clockwise. Okay, so we're starting here. Okay, and we're going to move to 90 degrees clockwise. That right there, we can put that our square because that shows it's a right angle, but that's negative 90 degrees. Okay, we already said that we went clockwise. How many revolutions? 1/4 of a revolution. So just because it's negative, that doesn't change how many revolutions it is. The clockwise changes from counterclockwise, but it's still 1/4 of a revolution. Beverly, you look puzzled. Do you have a question?
Yeah, I'm a little confused.
Okay, what are you confused about?
How come it's right there instead of on the other side? Cause
Up here?
Yeah.
So if we move this way, that's positive. So since it was a negative angle, we moved this way.
Oh, it's supposed to start on the X.
Yep, it always starts right here. So always start right there, and then if it's positive, you'll go that way. If it's negative, you'll go this way.
Well, I thought the other way was negative.
So what we start is we do 0, 90, 180, 270, all the way back to 360. So we'll start here and move all the way around. We kind of touched on it when we were doing vectors a little bit, because remember saying like we're starting here. We kind of touched on it there. But just from here on out, this will always be 0. You'll go around back to 360.
Oh, so that's the positive way, and you just go the other way that's negative.
Mm-hmm. Yep. And we'll use this too when we use the unit circle a little bit more, because if you look at your unit circle, you guys may still have it. If you don't, that's okay. But you start at 0, go all the way back around to 360. So it's kind of based on the unit circle. And we're going to do a lab on that on Friday, assuming that we don't have a bunch of crazy days in between. Okay, so we're going to combine some things going here, because 225 is a little bit different. So let's go ahead and draw our coordinate plane. We know that our initial side is going to start on the positive x-axis. Okay, would you agree that we're going to go at least 180 degrees?
Yeah.
Okay, so let's go ahead and assume that we start here. Okay, we're going to go 180. So if I do 225 minus 180, is that 45? Yeah. Okay, so I'm going to go 180 plus another 45. You tracking with me on that? We're going 180 plus another 45. Because if we do 180 plus 45, that's 225. Okay. So 180 plus another 45, that would put me right here. There's my 225. Okay, and you're going to see why I wrote those down in just a second. It's going to help us out with our revolutions. Okay, how many revolutions is 180? 1/2 of a revolution. So we went 1/2 of a revolution plus our 45 degrees, which is how many revolutions? 1/8 of a revolution. So when you get an angle that's not like 45, 90, 180, 270, you're going to have to do the plus thing. Okay, so you have to figure out how they relate to the ones that we know, then the 45, 90, 180. Okay, so the 180 was 1/2, the 45 was a 1/8. Now, last question, do we move counterclockwise or clockwise? Counterclockwise. Remember, it's kind of opposite of what you think until you get used to it. It'll become second nature. But we moved to the left, so that was counterclockwise. Would this be an alpha angle or a beta angle? Alpha, because it's positive. Okay, so we could label it an alpha angle. Yes.
You don't want us to combine the two revolution things?
No, you don't need to add those. Yep, we'll just leave it like that. Make it easy. Good question. Any other questions? Okay, last angle. 405. What kind of angle is this? Using a Greek letter. Gamma, right? Bigger than 360. Our initial side is going to stay the same. So we're going to start here. Okay, that's our initial side. we're gonna go 360 degrees at least. Yes?
Yeah.
Okay. So if I do 405 minus 360, yeah, that'll give me 45 as well. Okay? So I'm gonna go 360 degrees plus another 45 to get me my total 405. Okay, so when I draw this, okay, I'm going here all the way around plus another 45. So I'm going to end there. But here's how we show this. I need you to be careful about how you do this. Because we started here, we're going counterclockwise because it's positive. So we go all the way around and then we go back there. Okay, this is still our terminal side. That's where we're ending. So we did 360 plus another 45. How many revolutions is 360? One revolution. Plus 1/8 of a revolution. Okay, and do we go counter or clockwise? Oops. Okay, last two are pretty easy because you're just plugging stuff into formulas. Any questions on drawing the angles? Okay. So on our last ones, we're going to find the arc length of a circle. To do that, you use this formula here. S equals R times theta. So we talked about theta. Theta is an angle at standard position. Okay? That may also be called a central angle. Okay, when we're talking about a circle. And then we have R. Does anybody know what R stands for in this case? If we're talking about a circle, what would R be? Your radius. Yes, your radius. Okay. So we'll have S equals our radius, which is 2 meters, times our angle of 63 degrees. Now, if we're talking about a length, is the length going to be in degrees, or is it going to be in meters? Meters. So you're going to label the length based on whatever they give you in your question here. So this would be, is it 126? Yes. Meters. Okay. Now that may sound a little weird in terms of length because you're like, wait a second. If I'm doing a circumference, this is a little bit weird. But if you did a circumference, that's in something called radians. We just did it in degrees with 63 degrees. We're going to talk about the difference between radians and degrees on Wednesday. Okay? So that'll make a little bit more sense on Wednesday. Actually, maybe tomorrow. I can't remember if it's tomorrow or Wednesday. We may not have school Wednesday. Yeah. All right. Our last one is the area of the sector of a circle. So a sector is like a pizza slice. Okay. Think about if we're finding the area of one of pizza slice. Okay. So that's kind of what you're doing with the area of a sector. Okay. And again, I gave you that formula. A equals 1/2 R squared times theta. So in this case, we have our radius of 2 feet. Okay. And then we have our angle, which is 30 degrees. Okay. And you can just put that straight into your calculator. Which is 60. Okay, now, for our measurement, is this degrees? We're talking about area. Can area be degrees? No. What's it going to be? Feet squared. Okay. Or we could write it like this. Square feet. Okay. If we were doing volume, it would be cubes. Okay. But here we're going to have square feet. Tomorrow we'll do a little bit of a practice on this to start class. But on Canvas, so I'm going to make, this is going to be due on Wednesday. I think it's going to close at 7:30 in the morning. There is a history of trig quiz. Okay, it's 10 questions. With that quiz, there are presentation slides. Some of it is reading stuff, some of it's like quick 2-minute videos, okay, that you have to watch. The questions are literally exactly from the videos and the reading, okay? So if you just want to pull up one thing and pull up the other and just go for it, that's totally fine. Okay, you don't need to like watch it and then try to memorize it. Just pull them up right next to each other and do it that way. That'll be due before 7:30 on Wednesday because it's going to close Wednesday morning. So I would either do it. You have time now, obviously. That's why I'm giving you some time so you can get started on that. But you can either do it now or you can do it tonight, tomorrow night. Okay, but due by Wednesday at 7:30 it will close. Okay, that's all I got for you today. We'll continue tomorrow.